Bottled water is one of the fastest growing beverage categories in the world today.
Despite its simple appearance, bottled water is the result of a highly sophisticated production process.
Modern bottled water plants operate 24 hours a day, 7 days a week, without interruption. The journey of water from its natural source to a sealed bottle involves many precise steps.
The first commercially sold bottled water appeared in the United States in the 1820s at a spa in Saratoga Springs, New York.
Truly,
glass bottles were the only containers used for water until the mid-20th century.
The introduction of PET plastic bottles in the 1970s transformed the bottled water industry.
Perrier sparkling water became a global luxury brand after its international launch in 1977.
Pure refreshment for the way you move. Live healthy, drink water.
Evian, Volvic, and Fiji Water became household names as premium bottled water brands.
Today, bottled water has overtaken carbonated soft drinks as the most consumed packaged beverage in many countries.
Bottled water comes from several different types of natural and municipal sources.
Mineral water comes from protected underground sources and contains naturally occurring minerals.
Artesian water is drawn from a confined aquifer where water is under natural pressure.
Glacier water is sourced from ancient glaciers and is marketed for its purity and taste.
well water is extracted from underground wells that tap into aquifers beneath the earth. The source of water significantly affects its mineral content, taste, and pH level.
Premium brands carefully protect their water sources to preserve quality and purity.
Environmental assessments are conducted regularly to ensure sustainable water extraction.
Buffer zones are established around spring and aquifer sources to prevent contamination.
Farmers and factories kept at safe distance. Strict regulations govern the distance of farming, industry, and development from water sources.
This section correlates with the recharge zone on the map. The flow rate seems healthy, indicating good sustainability.
The turbidity levels are spiking rapidly. We need to initiate corrective measures immediately.
Confirmed. Adjusting the coagulant feed rate now.
Reforestation and land conservation projects. Companies invest heavily in reforestation and land conservation around their water sources.
Sustainable extraction rates are carefully calculated to avoid depleting underground aquifers.
As you can see, the license status is approved. All parameters are within the regulated limits.
Excellent work. The extraction can continue as monitored.
The long-term protection of water sources is both an ethical and a business priority for producers.
Environmental-friendly extraction infrastructure. The extraction infrastructure is designed to minimize any disturbance to the natural environment.
Submersible pumps draw water from deep underground aquifers to the surface.
Flow rates are carefully regulated to ensure sustainable and consistent extraction.
Extracted water is transported through sealed, food-grade pipelines directly to the processing facility.
The entire extraction system is enclosed to prevent any outside contamination of the water.
Control, we have a critical failure in Sector Gamma. I'm initiating emergency protocols.
Backup pumping systems ensure continuous operation even if the primary pump fails. Before processing, source water passes through a series of pre-treatment filtration stages. The first stage typically involves passing water through large sand or multimedia filters. Sand filter removing sediment. Sand filtration removes suspended particles, sediment, and larger impurities from the water.
Activated carbon filters are used next to remove chlorine, organic compounds, and odors.
Carbon filters work by absorbing contaminants onto the highly porous surface of carbon granules. Microfiltration membranes with pores as small as 0.1 microns remove bacteria and fine particles.
These filtration stages work together to produce water of consistently high clarity and purity.
Filter media are regularly backwashed, cleaned, and replaced according to strict maintenance schedules.
Many bottled water producers use reverse osmosis as a key purification step.
Reverse osmosis forces water through a semi-permeable membrane under high pressure. The membrane allows water molecules to pass through while blocking dissolved salts and contaminants.
Reverse osmosis can remove up to 99% of dissolved solids from water.
Contaminants rejected by the membrane are flushed away as a concentrated waste stream. 61. Pure water collection. The resulting water is extremely pure but may taste flat due to the removal of all minerals. Remineralization improves the taste of the water and restores beneficial mineral content.
Reverse osmosis systems require regular membrane replacement and careful maintenance.
Modern reverse osmosis systems are highly energy efficient compared to earlier generations.
After filtration, water is typically treated with ozone gas for disinfection.
Ozone is a powerful oxidizing agent that destroys bacteria, viruses, and other microorganisms.
Ozonation is the preferred disinfection method in bottled water production because it leaves no residual taste. Ozone is produced on-site by passing oxygen or dry air through a high-voltage electrical discharge.
The ozone gas is then injected into the water through diffusers at precisely controlled concentrations.
Ozone destroys microorganisms by rupturing their cell walls and disrupting their DNA. After ozonation, ozone naturally decomposes back into oxygen, leaving no chemical residue in the water.
Contact tanks ensure the water is exposed to ozone for a sufficient time to achieve full disinfection. Ozonation is widely regarded as one of the safest and most effective water disinfection technologies available.
Ultraviolet light treatment is another disinfection method commonly used in bottled water production.
UV light at a specific wavelength of 254 nanometers is highly effective at inactivating microorganisms.
UV radiation damages the DNA of bacteria and viruses, preventing them from reproducing.
UV systems consist of chambers fitted with high-intensity UV lamps, through which water flows continuously.
Clean, chemical-free water. UV treatment is chemical-free and does not alter the taste, color, or odor of the water. UV lamps must be replaced regularly, as their effectiveness decreases with use over time.
UV treatment is often used as a final barrier against microbial contamination just before bottling.
The intensity of UV exposure is carefully calibrated to ensure complete microbial inactivation.
UV systems are compact, energy efficient, and require minimal chemical handling by male South Asian operators. Combining ozonation with UV treatment provides multiple layers of protection against contamination.
Most water bottles are made from a plastic material called polyethylene terephthalate, or PET. PET is chosen for water bottles because it is lightweight, strong, transparent, and fully recyclable.
Injection molding of preforms. Bottles are produced through a two-stage process involving preform injection molding and blow molding.
The cooled preforms are then reheated in an oven to make them pliable for the blow molding stage. In blow molding, a metal mold in the shape of the final bottle closes around the heated preform. High-pressure air is then blown into the preform, expanding it to fill the shape of the mold exactly.
Bottles emerging perfectly formed. The blow molding process takes only a fraction of a second to complete for each bottle. High-speed bottle production line. Blow molding machines in large factories can produce thousands of bottles per hour continuously.
Rejected bottles removed. Bottles with any detected defects are automatically rejected and diverted from the production line. The inside of each bottle is rinsed with purified water or sterile air before filling begins.
Rinsing removes any dust, particles, or manufacturing residues from the interior of the bottle.
The wall thickness of bottles is checked to ensure structural integrity under filling pressure.
Label alignment sensors. Label positioning sensors ensure that labels will be applied in perfect alignment during labeling.
Ready for filling. Only bottles that pass every inspection check proceed to the high-speed filling stage.
Positive air pressure in the filling zone prevents airborne contaminants from entering.
Filling is done at very high speeds, with modern machines capable of filling over 60,000 bottles per hour.
The fill level in each bottle is monitored by sensors to ensure accuracy and consistency. The entire filling process, from rinsing to capping, is completed in just a few seconds per bottle. Immediately after filling, each bottle moves directly to the capping machine. Caps are made from high-density polyethylene, commonly known as HDPE plastic. The capping machine applies each cap to the bottle and torques it to a precise tightening specification. Tamper-evident rings on the caps are designed to break away the first time a bottle is opened. Capping torque is monitored continuously to ensure caps are neither too loose nor too tight.
Loose caps can allow contamination, while over-tightened caps may be difficult for consumers to open.
Capped bottles pass immediately through a capped presence detector to verify every bottle is sealed.
Labels carry important information, including the brand name, water source, mineral content, and expiry date.
Pressure-sensitive adhesive labels are the most common type used in bottled water production.
Shrink sleeve labels are used on premium bottles for a full wraparound visual effect.
Inkjet or laser coders apply variable date and batch information at very high speeds.
Cross-referencing the printout with the digital file now. The sodium count and allergen warnings are compliant for the US market.
Microbiological testing checks for the presence of any harmful bacteria, including E. coli and coliforms.
Chemical analysis verifies that mineral content and pH levels meet the product specification.
All tests passed. This batch is cleared for release.
Understood. I'll move it to distribution.
Physical checks of bottles include cap torque testing, fill level verification, and label inspection. All test results and production data are recorded and retained for full regulatory traceability.
As plastic pollution grows as a global concern, the bottled water industry is investing heavily in lighter bottles.